All right, so a couple days ago we talked about how to solve quadratic equations by graphing, and that was method one. Today we're going to talk about how to solve them by factoring. And then hopefully you remember how to factor. You've gotten pretty skilled at it over quarter three because we'll be using it a lot for the rest of this unit. So first let's review how to factor. So when you are factoring, the first thing you want to do is see, can I pull out a common factor, because that'll make the rest of your problem so much easier. So on this one, all of them are divisible by 2. So I'm going to pull a 2 out first thing, because if I can especially get this x squared to have a coefficient of 1, it is way easier to factor than if it has a coefficient larger than 1. So we have x squared plus 5x plus 6. And then at this point, I want factors of 6 that add to 5, which should be 3 and 2. So x plus 3 and x plus 2. Now, we've talked about this some, but not really in detail, so let's act like we haven't talked about it at all. It says now we can use these factors and the zero product property to solve quadratic equations. So the zero product property states that if I take a times b and it's 0, then either a or b has to be 0. So what that is saying is one of these two pieces, x, if this is equal to 0, because remember for our quadratic functions, our quadratic equations, we want them equal to 0 on the right hand side to solve them. This is saying that one of these three pieces has to be 0. So we know 2 can't be 0 because there's no variable with it. But if I want to make x plus 3 equal to 0, then that's going to make x negative 3. And if I want x plus 2 equal to 0, that's going to make x negative 2 when I go to solve it. So that is how we're going to get our two solutions today. In this example, we have x minus 3 and x minus 2. And again, most of the time we'll have two solutions. There are some edge cases where we just have one, or we might have none. So method number 2, factoring. This only works if it's factorable though. So there are cases where our solutions are irrational numbers. They're not nice whole numbers or nice fractions, easy numbers to work with. So graphing will always work. The factoring method only works if it's factorable. So we're also going to talk about some algebraic methods later and what to do if it's not factorable. So just because you can't factor it doesn't mean there's no solutions. So if it's not factorable, we don't want to say no solutions because that's not necessarily true. It might be true, and we'll talk about those more later. But for now, if it's not factorable, we just want to put not factorable instead of no solutions. So graphing always, always, always works. Although sometimes it's tedious and it's not everyone's favorite. So today we're going to work on factoring, which works if the numbers are nice. And it'll work on most of our examples we're doing. So here I want factors of negative 42 that add to 1. So I think we want 7 and negative 6. So we'll have x plus 7 and x minus 6 equals 0. Before you factor also, you want to make sure the right-hand side is set equal to 0 before you start. Then to make this piece equal to 0, I would need a negative 7, because negative 7 plus 7 is 0. And for this piece, I would need a positive 6. So these are my two solutions for this one. All right, so now I'm just going to work through, that's the gist. We're just going to work through some examples to get some of that muscle memory going here. So this time, it's already factored for us, which is nice, and we just have to find what the zeros would be. So this x should just be 0. To make this piece 0, I would need a 1, because 1 minus 1 is 0. For this piece, I would need a negative 2. This one is a little bit less obvious. So when it's less obvious what it would be, just take that piece, that binomial, and set it equal to 0. So I'm doing some scratch work over here. So to finish out this two-step, I would subtract 8 from both sides and divide by 2 on both sides. So this one should be negative 4. So I need a negative 2 and a negative 4. So when they're just like this, it's usually pretty obvious. If it's less obvious, you can always set it equal to 0 and solve the two-step. All right, so here's ones that are not already factored for us. Again, I would always take out a greatest common factor if you can at the beginning, if your leading coefficient is bigger than 1, because it's easier to factor those. So it looks like I can pull out a 2x here, and then I'd have x minus 10, and that's already fully factored, it looks like. So for my first piece, I would need x to be 0 to get a 0, and for this piece, I would need a positive 10. All right, this one we want to factor. My leading coefficient is 1, so that's nice. I need factors of 15 that add to 8. So I think 3 and 5 are what we want. So we'd have x plus 3 times x plus 5 equals 0. And then I would need a negative 3 to make this piece 0, and a negative 5 to make that piece 0. Okay. One more slide, we'll do 2 more examples. Here's an example of one where I would want to move the 10x to the other side because I need this side to be 0 before I start factoring. And you want to put it in standard form so that you have 5x squared, then the minus 10x with the minus 40 on the end. Okay, looks like I can pull a 5 out, so I'm going to do that. So I'd be left with x squared minus 2x minus 8. So we want factors of negative 8 that add to be negative 2, which I believe is negative 4 and positive 2. So we'll still have that 5 out front from our factoring, and then we have x minus 4 and x plus 2 equals 0. So now that this is fully factored, I can figure out what x should be. So to make this piece 0, x would be 4, and to make this piece 0, x would be negative 2. So there's my 2 solutions. This is an example of where I can't take a GCF out and I still have a leading coefficient larger than 1, so we'll have to use the longer way of factoring, where I'm going to want factors of 3 that add to be negative 4, which I should be negative 3 and negative 1. So then I'll have to use my box method where I have my 3x squared in the top left, my 1 in the top bottom right, and then instead of negative 4x, I'm going to put negative 3x and negative 1x. Okay, we split that middle term into the factors we need. So this would be a 3x I can pull out. Here we would have a negative 1 we can pull out, a 1x, and a negative 1 again, it looks like. So this factor would be 3x minus 1 times x minus 1 equals 0. So for this piece, it's pretty obvious that'd be a positive 1. And for this one, we might have to do a little scratch work. So 3x minus 1 equals 0. I would add 1 and then divide by 3. So I'm going to leave this as 1/3. So we have positive 1 and 1/3 as our 2 solutions there. All right, this is the end of our notes for today, so you are free to move on to your assignment.